input sequence for this. I mean, this is the input sequence applied to this figure. Okay, this is the figure we are having. For this figure, we have applied this kind of input sequence. We need to find the output. We need to find the output. Good evening, Sadbhavana. Let's start the discussion on Mealy and Moore emissions. Yesterday or what? Emissions. Yesterday we have done very good questions based on your sequential circuits. Please don't miss that class. Even at least you should watch recorded part. Rishi, you are having the habit of skipping the classes. It seems like you are skipping more classes. Okay, so let's continue. Good evening, Ganesh. So let's continue. Before that, yesterday, I'm not sure about it, Reddy. Maybe tomorrow. Or today I may give introduction. 90% tomorrow. Yes, Pupul, we are going to that. Yesterday I left one question. Now, what is that question? Let's upload. Let us upload it. I have given one question on monostable multivibrator. Right? So this is the question we have. Let's do it. So go through it. I will start doing the question. Shall I conduct the poll? Yesterday someone tried it. Okay, let me give you the poll. So read the question. Two monoshot multivibrators M1, M2 are connected on another. One is positive edge triggering, another is negative edge triggering. This one is a positive edge going. That is, whenever positive edge occurs, this will give you the output. So first one is having the width of T1. So it will generate a pulse of width T1. At the negative edge of this fellow will generate a pulse of width T2. So monoshots M1, M2 when triggered produces a pulse of width T1 and T2 respectively. T1 greater than T2, whatever may be respectively. What is the output voltage V0 of this circuit? Okay, so let me start the poll. Because I have given yesterday already as a homework, I'm not giving you much time to do this. So you can try. Okay, nice. So what is the right answer is this one. Let me do it. Why I copied this one? Okay, this is the figure given by examiner. So let us assume initially this is 0, this is 1, So this is Q is 0, Q bar is 1. This is Q2 only. Okay, this is 1 and here this is 0. So you switch on the system or you connected the 5 volts to the RC circuit. Now what happens after some time, this RC fellow will charge. Charge करने के बाद what happens after charging? Initially it is 0 only. 0 into anything is 0. So when the capacitor charges, then it will become 1 here. When it becomes 1, you will get 1 here. Once you get 1 here, that is 0 say 1 change has occurred. 0 to 1 means positive edge or negative edge? 0 to 1 change hua, that is positive edge. If it is a positive edge, at that time you will get a pulse of width T1. Okay, automatically at the positive, when positive edge occurs, immediately it will give you pulse of width T1. Okay, now at the end of this, at the negative edge of this, okay, initially it is 0 only. At the negative edge of this, what happens? At the negative edge of this fellow, this will change. At the negative edge of this, okay, say at this point, now this fellow will change from 0 to 1. Why? Because at the negative edge, it is equal to giving it a trigger. When you give trigger, it will generate a pulse of width. How much? T2. So when it is 0, this is 1. When it is 1, this will be 0. So this will become 0. So 0 into 0, what is the AND gate output? 0. Okay. After T2 time, what happens? After T2 time, this will on its own, it will become 0. When it becomes 0, again 1 comes. So then this changes from 0 to 1. Again, 1 into 1 will give me 1. So that is again a positive going edge. Is it clear? When it becomes 1, this becomes 0. So it will clear the AND gate. And again, when it becomes 0, this fellow will become 1. And again, what happens? 1 into 1 will give you 1. Capacitor is charged. Now it is fixed to 1 only. Only this fellow is changing. When it is changing from 1 to 0, bar is changing from 0 to 1. So you will get the trigger here. Then again, after the time T2, it will generate a pulse of width again T1. And after T1, again this fellow will generate a pulse of width T2. And this will be a continuous process. So what is your output is like this. It is on for T2, off for T1, on for T2, off for T1, on for T2, off for T1. Okay. When this is off, this will generate. When this is off, this will generate. At the negative edge of this, its bar will be positive and this will generate. Okay, so you can see what is the answer. T2 on, T1 off, T2 on, T1 off. Here there is no use of the information T1 is having more width greater than T2. There is no use of this information. Okay, so that is monostable. Yesterday class I have discussed, please go through that. In the doubt session, I have discussed two things. Frequency measurement using counter. Another thing is monostable multi-vibrator. If you want, if you missed yesterday's class, please go through that. Okay, so let me give you one more thing. Just 1 minute. I will give you one. So last lecture, if you remember, This is what we discussed. Okay, just go through all of the points. We have discussed everything in the class already. What is the difference between Mealy and Moore? Mealy may output depends on the present input and present state. Here output depends on present state only, whereas state depends on the output. So here output is asynchronous with clock, here output is synchronous with clock. It cannot change without clock. Okay. Here the output is defined at a node. Here output is defined on the arc or transition. That is between two nodes, whatever you have, there we define this output. Input can affect the output directly, so less noise immunity. Input cannot affect the output directly. Okay, cannot affect output. Okay, so more noise immunity. So less number of states compared to Moore. In the Moore, what is that? More number of states compared to Mealy. Here the design, that is output. I am not saying the total design. You can say output design is complex, or the external, other than flip-flops, external hardware is complex here. It is a simpler here. This point, I'm sorry. Okay, fine. So just please don't confuse. What, Chaitanya, you are present in a day before yesterday class or not? Please tell me that point first. So more noise immunity. Here less noise immunity. Immunity means it can take, I mean it can bear. So you can say meta stability. Meta stability means transients can occur. What is transients? If some input by chance some noise occurs, that noise can reflect in the output. Okay, that's all. Okay, now one more point we want to discuss here. Okay, two states, if for same set of inputs they have same next state and same output. They should have same next state and same output. Next line. When two states are identical, we can replace with a single state. Okay. So like that, if more number of states are there, more flip-flops are possible. So to decrease the number of states, what to do? We should check, is there any redundant states? Redundant means similar states, identical states. You can merge them into a single state. That is what we call state table reduction. You understand this question? Two states are identical. said to be identical if for same set of inputs they have same next state and same output. When two states are identical, we can replace with a single state. So let me do it. Let me give you an example. This is the question. Reduce the state table shown in the figure, comma, find the output for the following input before reduction and after reduction. So what is the input given by the examiner is okay. You can say input sequence. So this is the input sequence for this. I mean, this is the input sequence applied to this figure. Okay, this is the figure we are having. For this figure, we have applied this kind of input sequence. We need to find the output. We need to find the output for this input sequence. Firstly, for this figure. Then what I will do? I will apply the concept of state table reduction. Then again, I will find whether I will get the same output or a different output. So, are you ready, guys? Understand the question? So, firstly, tell me what is the input. Let's write clearly: 0, 1, 0. 1 0 1 0 1 0 0. Okay, if you want you can write here assume initial state equal to a. Assume initial state equal to a. Nothing wrong. Okay, examiner will generally give, not we by default we assume it as a initial state a here. Okay, this is your state and this is the corresponding output. So here start here with a. You only tell me you are in the state A. Suppose your input is 0. According to this figure, what is the next state? What is the output? Hmm. Wait. That is true. Enough. Now again, see here. You are in the state A. If your input is 1, you move to state B. That is the next state will be B. What is the output you give? 0. So let's fill this whole total. Okay, so firstly listen here. For B, if 0 occurs, what is the next state? C. For C, if 1 occurs, D. For D, if 0 occurs, E. For E, 1 occurs, F. For F, 1 occurs, F only. For F, 0 occurs, G. For G, 0 occurs. I'm wrong somewhere. Wait. Wait, am I correct? B0 is C, C1 is D, D0 is E, E1 is F, F1 is 0. Okay, no problem. Hmm. Okay, for F, if 0 occurs, it goes to G. For G, 1 occurs, it will goes to F again. For F, 0 occurs. Again, G. For G, 0 occurs. A. Right, correct one. Correct one. Now listen. For B, 0 occurs, output is 0. 0. For E, 1 occurs. You see, for E, 1 occurs. What is the output? 1. For F, 1 occurs. What is the output? For F, 0 occurs, output is 0. For G, output is 1. For F, 0. So if you give this sequence to the this input sequence, what is the output sequence you will get? It is this one. Okay. Now what is the example question? You just keep that as it is. Now what to do is try to find the output for this. Okay. What when in which condition? When you reduce the state table, find the output for the same. You reduce the state table and draw it again. Then find the output for the same input sequence. Whether you are getting same or not, we need to check it. Let us do it. So to reduce the state table, let's copy the figure again. Now see here. You are having present state A. Okay, this is the state table. What is the next state? Present state is A when x equal to 0, 1. Y equal to x equal to 0 and 1. What is the next state? What is the output? Okay, let us see from this figure. If you are in the state A, if 0 occurs, next state is A only. If 1 occurs, next state will be B. Okay. Next, listen here. When you are in the state, what we call, 1 minute please. What is the output in both the cases? 0. Next again, see the story. B, 0 occurs C, 1 occurs D. Both the cases 0. C, 0 occurs A, 1 occurs D. For D, 0 occurs E, 1 F. Because for D1, output is 1. Next, for E, 0 occurs A, 1 occurs F. For F, 0 occurs G, 1 occurs F. Lastly, for G, 0 occurs A, 1 occurs F. Now, identify the rows which looks identical. Identify the rows which looks identical. You should do this job. Is there any two rows which are identical? Very good. See the row E and row G. For same set of inputs, you have same next state, same F, same output. What does it mean? These two states are identical. These two states are identical. You need not have two states here. You can replace or you can merge with a single state. You accept it or not? So let us do that. So what I did, I merged the state, this one, E and F. I replace, sorry, E and G. I just replace G with E. Is it okay now? Understand or not? I just replace this. These two are same na. I replace G with E in the equation. Every state, every table में G is replaced by E. First step is okay. Up to this, any doubt, please ask. Up to this, any doubt, please ask. Leave that up to then. Nishita, okay, firstly tell me up to this, any doubt? G and E. Aditya, see here. Your 0 is having AF01. This is also having AF01. So are they same or different? They are same. That's why we replace G with E. Now, 1 minute. Who is that? Previous slide चाहिए, take it. Okay, happy? इसका previous कुछ नहीं. I didn't understand your question, Ganshu. Please ask your question properly. I didn't understand what you are asking, Udit and Ganshu. You want any 1 minute, Udit? 1 minute, Udit. You need any explanation in this? This is given by examiner only. This, see here, this is given by examiner. We took this input as it is here. Now for this particular inputs, you started with A. If 0 is your input, what is the next state according to the figure? In the A only, if 1 is the input, what is the next state according to the figure? If B is your state, if 0 is your input, what is the next state according to the examiner? Like that we fill the whole table. Is it clear? Okay, got it. What is your doubt, Ganshu? Please ask me. So now we just made a state table, that's all. For this figure given, we converted this into table. We made a table for this. Okay. Ganshu, please ask. You replace E with G or G with A. What is the difference, man? You do anything, nothing wrong. It doesn't matter. Both are okay. Because E comes first, we are comfortable with that. That's all. Otherwise, G equal to E, you can do replace G with E or E with G. Anything is okay. Up to this clear? So next level may now as something Nishita told. Yes, Anuj also told. Now what are the two which are similar? Tell me. You just remove this state. Then again you have the chance of D and F are same. So D and F are same. So let's do that. Yes, D and F are same. I marked F equal to D, and now what I have replaced? Every F is replaced by D. Every F is replaced by D. Just wait. I already told that, Rishi, you can replace E with G or G with E. Doesn't make any difference. Now, let me draw 1 minute, 1 minute, 1 minute. Let me draw the reduced state table. Okay, this is your present state. What will be the next state? When x equal to 0, x equal to. What is the output? Okay, that is what I am drawing is reduced state table. After total reduction of the state table, what is the answer here? You have the states A, B, C, D, E. Okay. So now, what are the next states? A, B, C, D, A, D, E, D. A, B, C, D, A, D, E, D, and again A, D. What are the outputs? I am just copying that. I just made a copy, that's all, nothing else. Okay. Now some people are saying that C and E are same. No, no, because for C it is AD, for E it is AD, but the outputs are not same. Outputs are not same. So no more. Further reduction is not possible. Further reduction is impossible. No more reduction possible. Here G total row should be same. Okay. Here EF are same in all the aspects. Then we may replace F with D. Then you should check replace F with D and draw the figure. Okay, no more reduction is possible. Now see here. So first stage you have done this, second stage you have done this. Now no more reduction is possible. So let's, if you want, you can draw this figure. So how many states are there? A, B, C, D, E. Okay. For A state, output is achieved. For next state for 1 is, for B, next state is C and D. For C, next states are A and D. For D, next states are EDs. For E, next states are A and D. Okay, we just made that as it is. Why B may 1? Which one? Okay, no problem. This is 0, 0. Okay, B to C is 0, 0. B to D is 1, 0. Okay, you understand? Now this is what we call state table reduction. Now what we need to prove, one more is there in our hands. What is that? What we need to prove here? We should prove that in this case and the previous case, what is that? The output should be same for the same set of inputs. That we need to prove. Let's prove. Okay, so let's take here. This is the reduced state diagram. What is the input we have earlier? Let's write the same input. 0, 1, 0, 1, 0, 1, 1, 0, 1, double 0. What is the state? What is the initial state is A. Okay. What is the output? So first write the states. State A, if 0 occurs, according to this figure, now you take this figure of this table comfortably. B. For B, 0 occurs, C. For C, 1 occurs, D. For D, 1 minute, 1 minute. For A, 0 occurs 1, B, 1 occurs C. C, 0 occurs 1 minute. Let's write properly. Okay. For C, 0 occurs. Where it is going? For C, 0 occurs A na. For C, 0 occurs A. For A, 1 occurs B. Okay, we started wrong. No problem, no problem. For A, 0 occurs A only. For A, 1 occurs B. For B, 0 occurs C. For C, 1 occurs D. For D, 0 occurs E. For E, 1 occurs D. For D, 1 occurs again D. For D, 0 occurs E. For E, 1 occurs D. For D, 0 occurs E. For E, 0 occurs A. End. Now write the output. Output A equal to 0. A0 is 0, A1 is 0, B is C, D0 is also 1. But E1, for E, when the input is 1, what is the output? 1. For D1 also, what is the output? For D0, for E1, for D0. Now you can check your answer here with the previous answer. 00001 101 00. 00001 101 00. For the same input, you got the same output here and same output here also. Okay. So what is the number of states here? So you can implement that same with less number of states. So number of states equal to 5. But unfortunately, number of flip-flops in this case also same. But definitely some hardware reduction will be there. You understand the concept now? Very good. So let's move further. Next question. Yeah, definitely. Depends on number of states. Okay. In this case, maybe same, but general it can decrease. Now, next question. Draw the state diagram of a sequence detector to detect a sequence 11011. This is examiner favorite. Overlapping and non-overlapping. Two cases. So what is sequence detector? What is the meaning of overlapping? What is the meaning of non-overlapping? Let us see. Suppose in a computer or in your particular what we call industry, suppose in your plant some sequence of events has occurred, then you should generate some kind of output. Okay, say you are in a pipeline, so washing machine only you take the example. Suppose the sequence of events has occurred completely, washing, whatever, soaking, whatever, all the sequence of events are completed, then you should give one output, your sequence is complete. Similarly, you are getting some data. In the data, whenever this particular sequence occurs, I should give some alarm or I should give some output. This is what we call sequence detector. For example, what is the meaning of this problem is like this. You are having the input like this. 1 minute. Let's take some data. Okay. So, right, Nishita. So whenever you see here 11011 comes, completion हो गया ना ये आपका sequence, then I should give 1. That is whenever 11011 comes, I should give 1. Then again start fresh. Read for 11011. Again comes, give 1. Again 11011 comes, you give 1. So whenever you identify this sequence in your total input, you should give 1. Otherwise, your output is 0 only. Otherwise, your output will be 0 only. This is what we call sequence detector. In this case, we call it as non-overlapping sequence detector. Okay, just to see the figure, Sushil, you will understand. This is the input bit of sequence. Like previous case, you got some input now. Here also you got the input, but system should generate 1 only when this sequence has occurred. According to this question, what is that sequence? When 11011 occurs, output should be 1. When 11011 occurs, output should be 1. 11011 occurs, output should be 1. Okay, so this is what we call non-overlapping sequence detector. There is another possibility. Let us take that. Now clear, Sushil? Just hold your doubts for some time. It will be cleared. Just wait. Let me take same data. Okay, same. Okay. Yes, input is randomly taken. There is no logic for the input. Here also, there is a possibility you should take like this. Whenever 11011 occurs, I will give 1. Okay. Now, this is 1. Okay. Now, I don't start from this. Here, I take 11011. 1 minute. Here, my aim is like this. 11011. There is a chance of this kind of output. In this kind of output, for this I should generate 1, and also for this also I should generate 2 ones are to be generated. This kind of sequence is called as overlapping. Because the two sequences are overlapped on each other. Okay, if you end of the one sequence, if you start freshly new sequence, this is called non-overlapping sequence detector. But if you take the end, but you take the common bits and the last and first also. If you take some commonality between the last and first part of the sequence, see, last two are ones, first two are ones. So you can also treat these last two ones as the first two ones of next sequence. Then it is called overlapping sequence. So here what to do? You should after 1101, you should take from this. Okay, now listen. Yes, I got it here. I will give 1. But I should take here also. Now you see, yes, here also I should give 1. Now you did 11011. Then nothing else. We stop. So in earlier 3 ones, here 4 ones will come. That is the difference. So 11011. Here also 11011. Nothing else. Okay. And here 11011. This is what we call overlapped sequence detector. Okay, sorry, it is not passed. I closed it. Okay, okay, wait. I have not copied properly, it seems. Wait. No problem. Not. It is in our hands only. We erase it. Okay. Yes. Don't worry. We change the data according to our wish. Is there anything else? Yes. 11011. Yeah. Here also another is possible, na? Yes. Wait. Yes, I will make it. 1 minute. Let's remove this bad data. Forget about that. The data is not looking good. Okay, let's take this data randomly. Now see here. Whenever 11011 comes, you should give 1 in the output. Then again, here you should read like this: 110011. No, 11011 you should give. Then again, 11011. 11011. So no. So here you should give 1 in the output. Here you should give 1 in the output, and here also you should give 1 in the output, 1 in the output. Let me make the rectangle so that it will be more clearly visible. This one and this one. And what is the overlapped ones? Here is this one. Okay. Any doubt in this, please ask. Now, any doubt? Okay. Why? If you understand, because this is nothing. We have not done the problem yet. I just explained the meaning of the question. Once you understand the meaning of the question, you can answer it easily. So everybody understand the meaning of the question? What is AD doubt? Ask him. Please copy paste now. AD, what is your doubt? Sir, first one has one overlap. Where is that? 11011. It is 110011. No overlap. Upper one. Here we are drawing only. Yeah, 11011. After the second. Here you are saying. Yeah, this is non-overlapping sequence detector. Why are you seeing overlapping here? This example is for non-overlapping. This is for overlapping. For your kindness, both the data are same. The same data I have taken here also. It is not different. Same data I showed two different ways to get the answer. So that is when you take the overlapping detector, this is the answer you will get. And when you take the non-overlapping detector, that is the first one you will get. Okay. So this is the same input only. Two different ways to analyze it. One analysis is non-overlapping. One is overlapping sequence detector. Any other doubts? Please ask. You get first kind of output when it is non-overlapping. You get second kind of output when you use overlapping sequence detector. According to our application, we may use any one of them. Okay, let's start. Let's start the design. Yes, is that. Let me take some water. Let's design it. Now listen. Earlier we have given one figure is already given. We have done some analysis. Now there is no figure. Problem is given. We are designing. We are making the figure. So be careful how to draw the figure. How to draw the figure? Let's try. Okay. See here. How to draw this figure? Assume S0 is the initial state. What is S0? Initial state. So every state is having two possibilities. Every state will have two possibilities. What are they? Your input can be 0 or 1. 1 minute. Every state will have two possibilities. If input is 0, what is the answer? What if input is 1? What is the answer? Two cases. Okay. Now you tell me what is the next state here. Okay, next state we are only giving the names. Let's give different names here. What is the next state? And this one is the present state. So presently system is at S0, that is initially. If 0 comes, I need 11011. Keep it in mind. First, I should get 1 to start the sequence. To start the sequence, I need 1. If I get 1, I will go to the new state. If I get 0, I will stay at the same state until I get the 1. Everybody understand this simple understanding or not? Forget about output for time being. Don't worry about your output. Okay, right. Now again take a S1. What is the meaning of S1? Now you keep it in your mind. One has already occurred. Then I name it as S1. You keep any name, ABCD, S0, S1. Your name also you keep. Now also two possibilities. Your input can be 0, input can be 1. This is input. Okay, I need not write every time. If after 1, if your input is 0, it is not my sequence. I need 1 1. I got 1 0. What to do? No, go to starting itself. You go to S1 when you have 1 in your hand. Okay. After it is initial, because a sequence failed, you go to starting only. So wait for the new sequence. After 1 0, okay, you should start fresh or not. First one comes, you should take it as a first one. You should start from the first point. So if after 1 0 occurs, go to starting. If after one occurs, then yes, it is part of my sequence only. 1 1, yes, this is what I want. Go to new state, name S2. What is the meaning of S2, sir? 2 1s has occurred. 2 1s has already occurred. Now again you have the possibility of input can be 0 or 1. Input can be 0 or 1. Now input can be 0 or 1. If 0 occurs, 1 1 0 is my state only. Yes, S3, very good. 1 occurs, what to do? This is important step of your total analysis. If you understand this step properly, your analysis is simple and you understand everything. Very good. Some people are giving right answer. S not S1, S2. Shall I conduct the poll here? Very good. Deep is ready for the poll. What is the next state? S0, S1, S2, S3. Okay. So E means none. It is your headache. I don't mind about that. Ready? You can see. So few people gave right answer. Hardly 20% of the class. Not even 20. Yes, completely design changes for different sequence detector. It is not universal. This is true only for this sequence. If it is a new sequence, concept is same, but your answers, your design will change. Okay. Now see here, your mistake. Please understand. Some people gave. Listen here. In the first two cases, if 0 occurs, it is not part of your sequence. You went to S0. Correct. Here 0 occurs. 1 1 0 is part of your sequence only. So you went to new state. That is also correct. If 1 occurs, 1 means triple 1. 1 means triple 1. Yes, this is a part of your sequence only. This is part of your sequence only. It is not something outside your sequence. Why? Because in this triple 1, you may take these two ones into consideration. After triple 1, 0, 1, 1 occurs. You should give output equal to 1 or not. Or after n number of ones, you got 0, 1, 1. You should give output equal to 1. Here sequence is not failed, sequence is halted. Here sequence fail hua. Here also sequence failed. You get something which is not part of your sequence, but here it is a part of your sequence. It has not went next, but it can wait at the same. Everybody, please listen carefully. Ask me if you have doubt. If you understand this, remaining is very simple. Remaining total is easy. Only this point you should understand properly. Very good. Okay. After double 1, any number of ones comes, you should wait for 0 because this is not failure of the sequence. It is a part of sequence only. It has not gone to next, but it is waiting, you can say in one way. Sequence is halted, not proceeded. Very good. So now let's move. So this is how you get the same state in the next also. Now Listen here. Again, same story. What is that? You are in the new state S3. What is the meaning of S3, sir? Double one and also 0 has occurred. Now again, two possibilities are there. Your input can be 0, input can be 1. See, after double one 0, if 0 occurs, after double one 0, if 0 occurs, where to go? Arey, why S3? By double one double 0 is not your sequence, man. Double one double 0 is a failure, so you should go to S0. Earlier triple one may this is part of your sequence. Here you see the last 3 bits. This is not part of your sequence. Here last 2 bits are part of your sequence. डबल वन जीरो के बाद जीरो आया, लास्ट 3 बिट देख लीजिए, इसमें 100 is not your sequence. Or last 2 bit or last single bit, you see anything is not part of your sequence. Understand the logic? You should design like that. Okay, don't design it to S3. Next, you are a designer now. Next. After double one zero, if 1 occurs, yes, go to the next state, S4. What is S4, sir? S4 is having 1101. Okay. Now, where is that? Yeah. Here also, two possibilities are there. It can be 0 or it can be 1. Now, if it is 0, double one zero one, after getting 4 bits failed, go to starting. Study from first. Fail hua, study from first. One subject failed, sir. No, study from the starting. Okay. If 1 comes, here it is your wish. You may go to here after double one zero double one. Your required content is obtained. Na? Why to go to new state? There is no new state here. Finish, stop. You go to S0 only again. But how to differentiate, sir? Wait. In all the first cases, all these cases, whether it is new or next is correct or not, until you get the total sequence, you should give 0 in the output. When you get this, you should give 1. This is the difference, you understand? Okay. If you do like this is called non-overlapping sequence detector. Why non-overlapping, sir? After getting double one zero double one, I am going to start the new sequence. I am going to the starting to start the new sequence, non-overlapping sequence detector. But if I do different, what is the difference possible? Sequence, overlapping sequence detector, I want to design it. Then what to do? You can only last is different, remaining all are same. Only last state only different. Okay, how? You take S4, same double one zero one, and wait, guys. Here 0 1. Okay, what will be the next state? What will be the next state? Okay, it is the same S0 only with output equal to 0. Okay, but here there is a difference. What is the difference you will get is after double one zero double one. Wait. After double one zero double one, you should give output equal to 1. But you should also treat these last 2 ones as first 2 ones of next sequence. First 2 ones of next sequence means 2 ones means which state? 2 ones means which state? Everybody comment now. So you should start from this point in that case. In that case, what is the answer you will be getting? It is should go to S2. Okay. If you design like this, it is overlapping sequence. Sushil, always ask when the flow is there. Okay, don't ask the first point after the end point. I gave halt here. I ask n number of times, you understand or not. Okay, at that time only if you ask, it will be more easy for you to understand. Okay, don't hesitate to ask me. Ganshu, what is the overlapping? Please listen, everybody. Listen here. 1101101. Like this, the sequence is there. After getting 11011, you should give one. Now what to do? What to do? You should consider these two last ones of the system as first two ones of the next sequence and give one here. Okay. After getting 11011, you should give one, and after by taking this last two, okay, as the first two of the next sequence. Okay. Now listen, Ganshu. If you take 11011 as one, last two as the first two of the next, so you assume these two as first two of next. First two has already occurred. First two has already occurred means 1 1. So last, after getting the answer, you should not start fresh. You should start from the data which is common. Here it is 1 1. That is it. Now who is the Sushil? Sushil, what is your doubt? This state. You see here, n number of ones ke baad 0 1 1 came. Okay. So after 1 2 ones, if another one comes, you should wait, because in 3 ones, these 2 ones may be your sequence part. Or you get 4 ones, these 2 ones may be part of your sequence. Or you take 5 ones, last 2 ones is part of your sequence. Now it is not failure of the sequence. So you should wait for 0. What is the problem? N number of ones comes also, no problem. Here you should give 1. Rahul, wait. Sushil, you understand? Okay, clear. Rahul, tell me, what is your doubt? If 3 ones comes, what is the problem in that? 10 number of ones comes, no problem. Finally, I will give the answer output equal to 1 only after this. You see, 11011 ke baad only you are giving 1. 1 is the output. Okay, don't take this one and this one. Don't say it as a 3 ones. 1 is the output bit. 11011 ke baad, if you get 1, okay, this one is not input data. This is output data. Rahul, please ask, what is your doubt? You are there or not? Okay, fine. So anyone having any kind of doubts, please ask. Otherwise, we will move further. We'll draw the figure. Shall I proceed? Yeah, 2020, they asked one question. Okay. Very good. When something new comes, every time you think of whether it comes in exam or not. You understand, you are learning something new, man. You should enjoy that first. Okay, some super logic you are able to learn. This will be helpful in so many designs, not only in the digital. Okay, in your VLSI design, whenever you're designing any systems, this mirror and mode logic will be helpful. But okay, enjoy that. It will come in exam or not. Last time it came, sir. Okay, will it come for WE people? All those things, don't worry about it. All those things are byproducts only. I always say the same thing. All those things are byproducts only. Okay, it is most frequently occurring in your exam, definitely. Of course, we stress more on whichever comes in our exam more. No doubt in it. So let's draw the figure. Maybe I have some slide of the figure. Yes, I have. So this is the state diagram of what? Overlapped sequence detector. Same figure. This figure I can, this S naught may, if 0 occurs, go to S naught. 1 occurs, go to S naught. Let me draw it for you again. You have the states S naught, S1, S2, S3, S4. If 0 occurs, 1 occurs. Okay. In S1, if 0 occurs, 1 occurs. In S2, 110, 0 occurs. If 1 occurs, then S3, if 0 occurs, go to starting. 1 occurs, 110, 1. After that, you should give 1, 1. If 0 occurs, you should give 0. 1 occurs, only this line will change. This is what is that? Actually, without this, we can draw this. Just remember the things. Non-overlapping. But if I draw like this, you don't understand. That's why I take all the states. State diagram. Okay. So only this line changes, you see. For overlapping, this line comes to S2. For this, it will go to S0. So what is the number of states? 5. So minimum number of flip-flops should be greater than or equal to log to the base to 5. It is 3. That's all. So shall I give you one more homework here? Implement the design. How to implement the design, sir? State table, input output table, K-map. Same story I did already for first example earlier, last lecture. Same way you can implement. Okay. You can convert Mealy into Moore. It is up to you. So that is about your total discussion of your Mealy and Moore state machines. Now we'll go to the problems. You see, I will give you all previous gate questions 2016, 17, 18, 19, 20, all the previous gate questions. Now we are doing it. All the questions came in your gate. All the questions you will be able to solve easily. Get ready. Get ready. So the first question comes. Get ready, guys. Without seeing the paper, 2016 they introduced this in your syllabus. I made this notes. It is till now every time question comes from this only. I mean, if you study this, you will be able to answer all the questions came in the previous. So this is the first question. I will start the poll, just give a reading. Yeah, I will wait. Done. If it, I hope it is visible. 0, 0, 0. This is 0, 0, 1, 1, 1, 1. So this is the story. So start the poll. Guys, ready? Here ambiguity means doubt. That's all. Only there. See, when you see complex terms, you may confuse. Don't confuse. There is nothing difficult here. Question is very easy. What is ambiguity? Don't stuck here. When you don't know what is ambiguous, if you start transitions from A where it is going, from B where it is going, from C where it is going, if you understand, you can answer it. Okay, so let's do it. Okay, so what is the right answer is C. Let me prove it. See here. So this is the figure given by examiner. Okay, x equal to 0, y equal to 0, z equal to 0, y, z, like that some table is given, some figure is given, state diagram. What is this, Mealy design or Moore design? Is it Mealy machine or Moore? Is it Mealy, Aditya? What happened to you here? Output is defined anywhere. Output not defined, only input and state are defined, means which state diagram it is. After this much discussion, you should not say Mealy. Output not defined, it is Moore design. Very good. So listen here. So let's do the analysis. Your present state is A. According to this figure, if you see outgoing lines only, X, Y, Z, all three zeros, what is the next state it will go? B. Next, if X, Z, 0, 1, X, Z, 0, 1, Y can be anything. What is the next state? X, Z, 0, 1. It will go to A only. That is X, Z is 0, 1. Y can be anything, means take here anything of your wish, 0, 1, 1. Both the cases, next state is A. Okay, okay. Now y1, that is y1 remaining can be anything. Here four possibilities comes. What are they? Xz 0, 0, 0, 1, 1, 0, 1, 1. All the cases next state is A only. Lastly, what is the condition? This line, that is xy 1, 0. Here two cases can come. What are they? Here where it is going? Okay. After seeing this table, check anything coming two times. Anything, yes. This is 0, 1, 1, and this is 0, 1. Wait. It repeats, but no problem. Even it repeats, same next state. Na? So this table is having no problem. This table is absolutely fine. Next, let's do the same analysis for the state B and state C also. So let's do for state C. State C, if your inputs are, see here, this one, xz11, xz11, what is the next state? A. Next state is A. The middle one can be 0 or 1, doesn't matter. Similarly, yz11, again, what is the next state? Yz is 1 1, next state is B. Okay, so this can be 0 or 1. Yes, problem came, doubt came to the system. You told here triple one comes go to A, but here you defined triple one goes to B. Then this is what we call ambiguity. Don't fill the total, not required. This is to be avoided. What is this? We call ambiguity. Ambiguity means your doubt. System is in doubt whether to go to A or B. So state C, transitions from the state C are not defined properly. How they have defined? Ambiguously. So now onwards, you don't have any ambiguity about ambiguity. Okay. Then you do one thing, Kritik, directly see the figure, identify 1111 here, directly 20 seconds may you will get the answer. Okay. Right? So here, if you get that point, strike that point immediately, you are lucky. But if you don't get that point, every time may not be possible. You check everything. If it is possible, yes, here 1111 is overlapping. So there is a chance of ambiguity. You can analyze directly like that, you get the answer, no problem. But perfect way is this one. If you are lucky enough, you may start from state C itself. If you are okay, then like we A and C. If you are very bad, A, B, C. You analyze all the states and realize the C is the answer. Okay. So that's all for this question, 2 marks question you got it. Now let's go to the next question. Are you ready? Don't read the question, just let me upload all the questions. Right. So let's do this question. I will give you the options 2, 3, 4, 5. Read it. Digital lengthy question comes means easy question. Read it. I will start the poll. Shall I start the poll? Okay, start the poll. Okay, you can see your leaderboard. Today Harsh gave 4x4, Suraj also 4x4, Ruchita 3x4, Deepak, Danpal, Robert, Abhinav, Rishi, RK Singh, Richa. What happened? So listen here. What is this circuit, man? Two ways you can answer it. You see the figure. Whenever your input is 1, 0, 1, you are giving output 1. After that, please see, if 0 and 1 comes, if again 0, 1 comes, it is giving 1. That is 1, 0, 1, it will give 1. Again 0, 1 comes, it will give 1. What is this circuit? Tell me here. 1, 0, 1, output is 1. Again 0 and 1, output is 1. It is a overlapping sequence detector of what is the sequence 1, 0, 1. So when 1, 0 comes, 1, 0, 1 comes, it will give 1. When 1, 0, 1 comes, it will give 1. When 1, 0, 1 comes, it will give 1. So how many times it is giving you 1? First one, second one, third one, 3 times. I didn't get you, Lucky. When output equal to 1, that is the required sequence to be detected. Correct, Lucky? Okay. So after this, if it goes to starting, we call it as non-overlapping. Who is that? See here, 1, 0, 1. After that, if another 0 occurs, if 0 occurs, and again 1 occurs, what happens? This is the sequence. Okay, 1, 0, 1. After this 0 occurs, 1 occurs. Output में 1 आएगा ना? This is what we call overlapping. You understand? 1, 0, 1 will give 1. After that, what it is doing? It is going back to here. Okay, if 0 occurs. If 1 occurs, okay, it is starting 1, 0, 1 के बाद. If another 1 occurs, it is going to 1. Okay, that is okay. If another 0 occurs, what it is doing? It is going to this state, and another 1 occurs, it is immediately giving 1. So second time 0 1 itself will give you 1. 0 1, every 0 1 will give you 1. That's why it is overlapping. Even you don't identify with this is overlapping sequence detector and all, no problem. I gave another method now. What is that? 101 01 1 01 00 110. I didn't get you. What is your doubt, Rohit? Please tell me if you have doubt. Now see here, you don't know it as a sequence detector. That point doesn't strike in your mind in the time at the time of exam. No problem. Start from, you take this as S naught na. Start from S naught. I gave another method na. S naught may 1 occurs. What is the output? Tell me. 0. S naught may 1 occurs. Where it will go? S1. I told this method, you remember or not? If S1 may 0 occurs, it will go to S2. And S2 1 occurs, it will give 1 and go to S3. Like that also you can do. This is another way to do the question. Yeah, question weight is given. Okay, if it is not given also, you can find it here. I told it is overlapping sequence detector. Now, what is your problem? I didn't get you. Rohit, tell me what is your problem? Question is asked for this input, what is the output? Simple question. Okay, they don't ask you how many are overlapped. He said it is a overlapping sequence of 3 bits. It is, this system is to detect the overlapping sequence of 3 bits. Even he don't gives also, you can identify that. Everybody understand this? Any doubt, please ask. Now I will ask one question on this question. Is there any redundant states? Is there any redundant states or identical states is the best word you can use? And I forgot to announce you finally your networks class is finalized August 3rd, 7 a.m. to 9 a.m. Okay, you got the announcement because there is another batch who is attending this. Those are so because of that timings are not in my hand. So finally it made it as 7 to 8. Sorry, 7 to 9. Okay. So come here, please tell me the answer. No, Amitabh. It is fixed. It is done already, scheduled. Remaining people, please tell me, is there any identical states is my question. That is your observation is required here. Actually, to detect the 101, you don't need 4 states. You don't need 4 states here. S1 and S3 are same. Correct or not? Let us check it. For S1, your input 0 and 1. What is the 1 minute? What is the next state? And what is that? What is the output if input equal to 0 and 1? For S1, if input is 0, okay, it will go to S2 and output is 0. If input is 1 in the S1, this is S1, if input is 1, it will go to S1 only. output equal to 0. For S3 also, S3 means this state. If input is 1, it will go to S1 with output 0. If input is 0, it is going to S2 with output 0. What does it mean? Both are identical. Very good observation. S1 and S3 are same. Okay, you can remove this. Actually, examiner has not done. You can do it. Okay, reduction of state table is possible. There is no need of that S3 state. You can remove it. That is not given, not a part of the question. They can ask like that also. So let's move to the next question. Read the question. It is also a previous grade. Now you see our concept. If you are clear, all questions you can answer. This question is very simple. 2 marks freely comes for. Read this question. I will start the poll. RK Singh, Abhinay, Ruchita, Lucky, Mohan, Alcha, Danpal, 3 by 5. Very good. So now, what is the right answer here? So very simple question. If you understand, if you decode the logic, very simple. अरे मेरा पास 3 LEDs है, green to yellow, yellow to red, red to green. It's a cyclic process. Green, yellow we call generally amber, red. Traffic signal you are designing. This is for 70 seconds. This is for 5 seconds. This is for 75 seconds. Okay, red should be for more time. It should test your patience. So total time kitna? 150 seconds. Your clock is how much? 5 seconds. So total clocks is 150 by 5. It is 30. So you should see here. The question is the traffic signal cycles from green to yellow, yellow to red, red to green. In each cycle, green is for 70, yellow is for 5. Okay, yellow is for 5 and red is for 5. The traffic signal light is to be implemented using a FSM. The only input to the FSM is a clock of 5 seconds. Clock of 5 seconds. Okay. So the minimum number of flip-flops is, so number of flip-flops is equal to log to the base 230. That will give you number of flip-flops is equal to log to the base 230, which will give you 5. You may have the doubt, sir, here, why can't I take green as one state, red as one state, yellow as one state? So 3 states I can do the design. Yes, that is also possible. In that case, you can do it with 2 flip-flops. But here the question you read, what is the input? Only input to this FSM is what? Clock. So you should have a counter to count 0 to 29. Okay. So when you should design like that. I'm showing you. If you want, I can show you the design. Listen. You can try like this also, but that is a different case. Here, question by this point is also important. The traffic light has to be implemented using this. The only input to the FSM is what? What is the only input is clock. So it is like a counter only, which will count. Whenever count becomes 14, then it should go to next state. Whenever count becomes 15, it should go to next state. Whenever count becomes 39, it should go to next 29. It should go to next state. So like that, you should make one output logic such that whenever count reaches this value, go to the next. Count reaches this value, go to the next. Okay. So when count is equal to 0 to 13, it should be green. When it is 14, it is yellow, and 15 to 29, it should be red. That's all. You should design output logic. Okay, for this part, you can make a K-map for this now. For this, it is green. Okay, you can design it easily with the K-map. Guys, okay? So what is the right answer? 5. Now comes to this question. This is 2020 gate. I think double E, electrical engineering only. Get ready, guys. Ready, guys. I will start the poll. What happened, Aditya? It's a simple question for you now. Now it is very simple question for you. I will start the poll. I want more right answers from you. Just read the state diagram of a sequence detector. See how many times examiner loves this sequence detector. Is shown S0 is the initial state of the sequence detector. The output will be. You need not effort another extra time for this. Only our lecture is sufficient. Just this 2 hours of can give you 1-2 marks. This 2 and previous lecture PDF study happily, that is sufficient. So start the poll. Yes, I started. Why less answers, man? %40 only. What happened? ये तो बहुत easy question. Not visible. Just move your screen. First option is 0, 1, 0, 1, 0. I will give the time more time. See the second option. What happened? Done. So this is the final board. We can't do anything. So leave it. So now guys come here. So what is the sequence it is giving? 0, 1, 0. See this and okay flow 0, 1, 0, 1, 0. It will give 1. Okay. When you are getting 1, just to see that. You should get only this path 0, 1, 0, 1, 0. 0, 1, 0, 1, 0 will give me output equal to 1. Simple question. Freely you will get the marks. What is the doubt in this? Why few people are not able to answer this also? Kya hua? Don't say 0, 1, 0, 1, 1, sir. No, when you are getting output equal to 1. You see options only, that is also enough you to answer it. You don't ask whether it is overlapping, non-overlapping, nothing is asked. Simply he has given the figure, he asked what is this detector. So 0, 1, 0, 1, 0. It is a overlapped only. If you want to check it, it is a overlap. After 0, 1, 0, another 1, 0 comes, it will give 1. That is not asked by exam. You understand? Shall I move further? Kya response come? Please respond. Okay. What happened to Chaitanya? Output reverse आने पर भी मिलेगा. Okay. Now the next question. I will start the poll. These are the options. A sequence detector is designed to detect the previously 3 digital bits Okay, with overlapping sequence detectable. For the sequence, at least this question give 100 answer. This is also 2020 paper only. For the sequence 101 and the input of this much, what is the output detected? This much easy question. Start the poll. Okay, 1 minute. Not matching the options. What happened? Why that is happening? Am I wrong somewhere? Okay, 1 minute. Let's give new options. Maybe I copied the question from wrong source. Don't worry. In exam, it is not the options. I will change the options. Don't worry. As I can't change only one option, then you can say that is the answer. So I am changing all the options. One minute, it is matching the options. Wait. Options are matching. So let's start. Are you ready? Very good. Around 70 per 60% right answers. I'm happy. Harsh and Suraj, today's winners. Abhinay, Rakesh Singh, Deepak, Ruchita, Kronal, Lucky, Mohan, Aditya. Okay, fine. Okay. What is the answer? See here. What is the sequence given by examiner? 1101 0 0 1101 0 1 1 0. Okay. So see here. Whenever 101 comes, you should give output 1. You should give output 1, output 1. Remaining cases, it should be 0. That's all. So here he has not given the first 2 bits. Leave it. You take this part only. That is available in the options. 0 1 and 5 zeros 1 0 1 double 0. You should satisfy your examiner. Okay, sometimes he has given from this point. So that's all about yours, what we call FSM. You can see two consecutive ones can never occur. Two consecutive ones can never occur. Okay, not one more. We do few more. Don't worry. Two consecutive ones never occur because 10101 after this compulsory 0 comes, then only 1 can come. You cannot get two ones side by side here in this sequence detector. Like that, you can eliminate these two options if you want. And somebody told three ones are there only here, that is also way. So n number of ways you can eliminate the options. Okay. So now, okay. Draw the state diagram of implement the flip-flop whose state diagram given below using SR flip-flop. Using SR flip-flop. Let me draw this question. I made this question. Wait. This is your AB. You have one flip-flop, convert into flip-flop conversions we have discussed now. Flip-flop conversions we have discussed. Okay. The same thing you should apply, but there I give table, here I have given something else. It is easy for you now. Okay. Let's try option A, S equal to one. Okay. Shall we start? Thank you, Alicha. I need to give you solutions for DP. People are asking in the group. Okay, today or tomorrow morning, I will upload them. Tomorrow we start with the data converters. Sura is very good. Finally, you made it 8 by 8. Top. Harsh, Abhinay. Harsh is 7 by 8. Abhinay, RK Singh, Alicha, Deepak, Mohan, Danpal 5 by 8. Sriram and Rusta 4. Thank you, Rohit and Alicha. So, what is this question? It is nothing but a JK flip flop only. What is this? JK flip flop. It's nothing but you remember excitation table sufficient. You are in the 0. If 0 0 or 0 1 comes, see here Q equal to 0. Your AB is 0 0 or 0 1. What is Qn plus 1? It is 0 only. 0 0 is no change, 0 1 is 1. Similarly, when it is in 0, if it is 1 0 or 1 1, you go to 1. Okay. I just write this table into different way. Similarly, you are in the Qn, AB, Qn plus 1. According to this figure, if you are 1, if your input is x0, x0 means it can be 0 0 0 1. What is the next state? 1. You are in 1 only. If input is x1, x1 means 0 1 or 1 1. Here it is 0. Okay. So every time 0 0 will give you no change, 1 1 will give you toggle. 0 0 will give you no change, 1 1 will give you toggle. 0 1 will give you, wait, I am wrong somewhere. x0 now, okay. 1 0 will give you 1, 0 1 will give you 0, 0 0 will give you no change, 0 1 will give you 0, 1 0 will give you 1. Okay, this is nothing but if you remember excitation table, job is done. Okay, so it is nothing but what is JK flip flop. So J Qn bar KQn. This already you know it now, AND gates. Okay, so I give you small homework. Can you do it? Draw state diagram of all flip flops. For JK, just now we discussed. What is that? Q0. It can be 1. Okay. So what is your JK? 0 cross 1 cross 2 cross 1. Okay, like that you draw all the flip flops. Okay, guys, that's all for today. Any other question you thought? You want one more? Can I give some homework? You can try this question. Sequential is completed. Today I will upload the notes. I forgot one good question. I'll give it in exam. Don't worry. Yes. Okay, you try these questions as homework for today. So draw this also. Draw the state diagram of all flip flops. One more question I want to give you. Right. I forgot this question is in DBT or not. I forgot it whether I have done it or not. One more last question. This I have done already in the class because of RIB batch. I confused. I have done there. I have done here or not. I forgot. Okay, this also very good question. Okay, that's all for today. We can meet tomorrow. Bye bye. Tomorrow we start with the new topic, data converters. Good night. Your sequential is done. Now sequential is, I hope, not difficult for you. We covered everything on sequential. After data converters, okay, we'll see. Yeah. Sura, I will upload it. Good night, everyone. Thank you. Bye bye.